Welcome, everyone, to the second session of the Waku Hackathon demos today. This is the second Waku Internal Hackathon of the year. I'm excited to bring you the next round of presentations and panelists. We'll jump right into things here with our first presentation from JS Waku team member Arseni. And following that presentation, we will have a panel with some feedback, perhaps some questions. We do encourage you, wherever you are watching, whether it's on X or YouTube, to like and share and subscribe and turn notifications on while you're at it. If you are so inclined to use the chat there in front of you on YouTube and X to submit your questions or give your feedback. Let us go now to Arseni's presentation as I bring him on stage.
Hello. Okay, so I'll just jump right into it. One of the things that we focus on as we develop Waku, especially on the JS Waku side, is making it as easy as possible for developers to try, learn, and use our libraries. So one of the ways we do this is by having documentation, and there are some challenges associated with that, so I'll demonstrate that first. So this is our main website. We have a link straight to the docs, and there's more links, videos, explanations, etc. If you want to start building, you click Start Building. Takes you straight to the JavaScript SDK page, more links, more videos, and then here's some information to install, right? So if you already have a project that's set up with NPM or Yarn or whatever package manager, you'd copy this, open a terminal, paste it in, right? If you don't already have a project ready to go, then you'd need to set up a project, initialize it, paste it in there, and then get going from there. Otherwise, you could clone an existing example. So right now, we have all of our existing examples in this repository. If you just want to try it, for example, I don't see the link to it, but any of them, like the Notes app, then you open it here, and it'll load, and if you want to get the code, then it just takes you to GitHub page, so you'd have to go back to the repository, hit code, clone it, etc. And from what I understand, I'm not sure where exactly these are linked. So what I wanted to explore is, how do we reduce the number of steps that a developer has to take from learning about Waku or landing on the web page and then being able to actually try it. I evaluated different approaches. So one common thing you all might have seen is, in browser IDEs like StackBlitz, which just takes an entire GitHub repository and provides you with a way to build it, run it, edit the code entirely in the browser, which is cool, but it's a little bit overkill. There's I don't really need, if I just want to quickly try a project, I don't need extensions. I don't need to push to Git or look at all these files. So instead, what I found I mean, I evaluated all sorts of options, but the one that I've found had the most luck with is something called Tutorial Kit. And so in Tutorial Kit, once you land on a page, this is what you see. On the left-hand side, you have your actual tutorial content. So, information about how to create a Waku node. What is it? You have tips, links to more info, more information about, in this case, it explains like what our health monitoring, and then finally a task of what a developer would need to do to the code here to take it from a template to an actual like running working example. Or if they don't want to do that, they just want to see it, or like you're either giving a presentation, you just hit solve and it will preload the quote unquote solution. And now we have a node running. We have this code running in the browser, running in the network, and if for whatever reason I wanted to change things, connect it to the nice Waku network, it's refreshing like as I'm making these changes. And we only expose the files that are relevant for this lesson, they're called. So if we want to, like, we can actually hide some of these files and only expose this JavaScript file, and then this would still be run by the example, but it would be hidden. And they can be set up in a way similar to how we have our existing tutorials set up, although right now they're kind of I think they're ordered by like most recently updated. But it could be set up in a way where you go from super basic stuff like creating a node and just getting health events to a fuller example where it explains a bit about light push and filter, about sharding, content topics, creating decoders, sending and receiving messages, and a task where you end up making something a little bit closer to a working application. So here it's set up filter and light push, it sent a message, and if I take this same page and run it in another tab, so you see here, this section, something called the web container. It's like a completely isolated container, I guess, that installs all the dependencies we have here and actually starts a server that serves the bundle that we're building. But yeah, so if we run it now, you'll see it sent a message. If we go back to this one, there's two messages. So this is like an actual JS Waku node that's running here, that's establishing a connection to the other node I have running here. And we can also use this to host and show the same examples that we have in lab.waku.org, but in a way where it's a little bit more interactive. You have some information on the left side. You have all the files here. It even supports TypeScript. And we have we call this our dog fooding app that we typically use to evaluate new versions to evaluate like any changes that we're making. So similarly, if I hit start continuous sending, our node should start sending, and then I already had an example running here, and it's receiving those messages. And I added another example. So retro chat, this is something that Frank had made to demonstrate our reliable channels. And you see how quickly I went just from checking out one example to a different one. being able to look at the code to change it if I wanted to, etc. This is really useful because if you go to like this page, for example, there's a couple challenges with this. One is that these get out of date, and not only for potential developer, but even for me, it's not immediately clear whether or not like the code in these examples is going to work out or not. But if it's in this environment and I try an example and I run it and it doesn't do what I expect it to do, or there are build errors, or if there are console errors that we're not expecting to see, that's expected. It just can't establish a WebSocket connection. Otherwise, the example is working. Anyways, like when I run it here in this environment, it's very clear whether or not an example works. Plus, this framework, I guess you could call it, tutorial kit, is extensible. So I added like this custom component. I don't know if you can see it, but it lets us change the SDK version. So right now it's set to 0.35. We can switch it to 0.34. It'll update the package.json and it'll rebuild. So it's useful when we have, like when we publish a preview version to Next and we want to quickly try it out. So even for the developers, like we often use this dog fooding app. It's useful to be able to quickly open this website, switch the dependency, see what breaks, see what didn't break, make sure that it's doing the things we want to do, and even like observing these charts, these metrics. Yeah, I mean that's about it. Any questions?
Thank you, Arseni. We have our panel members on stage, Giuliano and Pedro.
Can we start talking?
Yes, please. Fire.
Okay, I mean, I think this is great. This is really good. I think usability, or rather developer friendliness or user friendliness, has been a long-standing problem for our projects. And we've been personally gone through the pain of putting together these tutorials and only seeing them like fall out of date as you update the code, and then things don't work, and then maybe you update it, but then we didn't have versioning in our documentation, so now you have some documentation that works but not for the previous versions. So this thing seems to sort of solve all the problems in some sense. So I think it's I mean, it would be really beneficial to use it. We would benefit from using it as well. That said, I don't think I don't think it can replace all of the examples in some sense, because I think one thing that is a characteristic that I see for good documentation is that it has this, at the same time it summarizes what's important to you and throws it in your face right as when you sort of enter the project's website, but then it allows you to drill down into things, and it's clear about these things as you drill down into them. So I feel like this thing is a little more into the drill down part of things, but it doesn't really free you from having that maybe set of very small examples that you sort of throw into people's faces and say, look how easy this thing is to use. You just import this and set this up, and then you start using it. And if you're not able to do that, maybe that says something about your library, right? If you have to like pre-explain a lot of things, then maybe that still tells you that you have too much complexity. One thing, I have mostly comments. I don't have criticism, because I think this is a good idea in general. One thing is, like, you still have to test your tutorials manually. I felt like this is a huge problem for us because, and I was actually suggesting, let's take those snippets and embed them into things that run into CI, so that if they fail, we're at least aware of it, so we can sort of map it and update the corresponding tutorials. Of course, we never got to do that, but if you could test this automatically, it would be amazing.
I think that is so sorry, go on.
Yeah, okay, good. I mean, if it's possible, even better. The other thing is, another thing that I've seen that was hugely popular with React was stuff like Create React App, which sort of puts together this kind of minimal scaffolding that you can use in your own editor. But I don't see this as competing with what you put together. I think this is more like maybe a complementary approach. If you want to like have some quick scaffolding, then maybe that's useful instead of like cloning things, and then maybe you have some small CLI that just bootstraps some pre-configured a version of a project for you to work with. Yeah, otherwise I think it's pretty good. I mean, if you guys follow this route and have this online, I think that would help the project. This is definitely something I would consider for ourselves as well.
Do I have time? Do I have time to respond, or do we
Rebuttals?
not rebuttal, but
of course.
Yeah, so I do agree. This is like it shouldn't completely replace like what we have. So it was inspired by the Svelte documentation. So they have their docs page, different sections, more traditional. Then they have these guided tutorials, kind of arranged by topics and different features. And yeah, like it doesn't. It's almost like another entry point for the developer to try, learn, and evaluate the project. And yeah, and eventually it would be great to have something like this, where any part of the logo stack that like can be can be like used in a web environment, which presumably will be all of it to some extent. That eventually we should be able to provide like an environment that does have lets them try like everything together. But yeah, it needs to be used like critically. It's not like it's definitely not a foolproof solution, so to speak.
I have one last question actually, which just occurred to me. Of course, you have your test. You're doing this for JavaScript library, but can you is this easy to sort of make it work with other, like, oh, I have a NIM project that I want to have my tutorial in? Will it? Okay.
Potentially. Right. So it's built on web containers. These are dev environments in a web app, but they support major frameworks and they support WebAssembly. So if there's a way to compile the NIM to WebAssembly and reliably run it in WebAssembly, then yeah. Outside of that, it might be a little trickier. And then the other part would be this code editor is using CodeMirror, and I had a bit of trouble trying to extend it a little bit more within the context of Tutorial Kit. So, like for example, I wanted to get actual kind of IntelliSense working here. So for our libraries, if I had typed in, the dot here, it'll show me an error immediately, but it won't show me like the options that we get from the light node. That was initially what I wanted to do, and I tried like creating my own version, and that was a mess. So theoretically it's possible, but it would require like more work. And then yeah, for NIM, I think for using it with web containers specifically, it would need to compile to WASM.
Yeah, I mean, I know it might sound like a stupid question if you're assuming this just runs on the browser, but I was like, maybe you can like set up backend somehow, and then you do these things somewhere else. And,
yeah. I think you can do Docker and WASM nowadays.
Oh shit! Okay.
I swore I've seen something like that before, or yeah, something crazy where you're You just have a Docker that runs into Wasm. Usually, it'll, like when I just searched, it was mostly giving me Wasm in Docker, but there might be Docker in Wasm. But yeah, the more we stray from just the web stuff, the wilder it will get for sure.
All right, good. Thank you.
Pedro, any comments, feedback, questions?
I'll be quick here. I think it's a very nice solution for onboarding new people, like for demoing, rather than just. I mean, even as a standalone, it's pretty good. But I think where this would really shine is like in an onboarding call, like to have more of a sales demo approach, so to speak. It's a very interesting resource, and yeah, delivering this first on such a context, and then letting the person in question just use it afterwards, and if they you want to go that far, just read the docs and look at dive into the GitHub. But I think this is a great gateway to onboarding people. I think it's a very interesting approach to the beginning of the journey. I think it's friendlier and more welcoming than just the docs and the GitHub repos, just sending them over that stuff. So yeah, I think it's a good upgrade.
Sweet, good to know. Yeah, I can imagine like adding, like this is publicly posted. Presumably, if it's like in a sales or like still, talking with partners, we could even, make it private to them and add an example that's like specific to their use case.
Yeah, that's interesting. It's not. I think the fact that it's public doesn't change much, because you still have to take people there and make sure that they are looking at the thing. While if you just send a link to them, or say you meet someone in an event, say, we have this tutorial thing, it's public. It's not the same as really getting on a call and having like this demo flow. And yeah, if there's a possibility of doing like use case specific versions for a given potential partner, it becomes even more interesting. Yeah, because we have been doing this type of thing with some partners. Like Vaslav will quickly vibe code a small demo of the use case using Waku, and this is something that has had interesting reception and results. And if we can mimic that into this dynamic, it would be very interesting.
Yeah, definitely. So I only ported over like a couple of the tutorials and a couple of the examples, but we'd want to think about like, okay, for completely new developer, exactly which one of these are critical. And I'll also, this is going to change as we like develop, as we like build out the API. And then for the examples too, like more complex examples, like I know that signature aggregation is something that a lot of people are interested in. So it'd be cool to have like a more robust signature aggregation example with instructions also to like, open it in a second window to actually like try it out, blah, blah, blah. But yeah, that is good to know that it's useful in your context as well.
For folks in the audience that might have questions or feedback, please feel free to use the chat and submit your questions and get it in quick as we are wrapping up this portion of the presentation. Thank you, Arseni. Where can people go to maybe check out this, if it might be live, or get more information? Oh no, can you guys hear me?
Yeah, I can hear you. I was just gonna say, yeah, it's live on JS-Waku. I don't know if we can just post that.
For curious viewers, we will make All links available shortly. Thank you,
Sweet.
Arseni. Next up, we have Fabiana.
Hello, my name is Fabiana. I am a Waku engineer, and this is my internal hackathon weekly projects. The idea is to restore fun to home hashing. So if you remember the early days of Bitcoin, you could just run a program like Bitcoin QT. You leave it running and you get tokens, and that's really cool. But this was ruined by hardware acceleration. So with ASICs, they have a 200,000 factor gain over CPU, so it's no good to earn tokens with your CPU anymore. And but with recent developments like RandomX, which is Monero's hashing function, which is built to be a proper VDF, you can have this activity be democratic again. So you can actually, it's meaningful to participate in systems with hashing with your own computer at home. So the idea here is not to use proof of work to secure a blockchain, but to use it as a pure Hashcash system, right? So you just compute a proof of work stamp over a message. You distribute it through some digital system, which can be anything really. It can be a website, it can be a blockchain, layer 2, or it can be a P2P messaging system also, right? And the goal would be to use these stamps. They would come from like pseudonymous nodes, and it would allow you to give a rate of service to a remote host without it having to identify itself, create an account, create a login, and not even install software, because you could run something like RandomX in WASM also. So I designed a proof of work Hashcash system that could run over like any decentralized chat medium over Waku, for example. So I created this message struct here to describe the single message that the system would have. I won't get into the details, but basically what this message means is that you have some public key that is attached to the proof of work hash, right? So, and if the proof of work hash has a difficulty target of, let's say, 200 work units, you would get granted in the system like 200 tokens. And if it has 400 difficulty, it would be 400 tokens, right? So it's just a Hashcash system, a pure Hashcash system. And inside the same message, atomically, you can also pay some other public key, some amount. Nodes would collect these messages, just simply sort locally them in timestamp order. And the state of the ledger, in this case, it would be just the result of replaying these messages in order. So if you look at this very simple system, what are the security properties? First thing, well, there is no spam because it's a Hashcash system, and a Hashcash system is designed to resist spam, first and foremost. Message ordering is determined locally by each node individually, so there's no consensus or coordination. You can just determine everything locally. And the only adjustment you need is that you do not accept messages that are too old, like after a certain threshold, which is how you keep the double span database in an acceptable size. So you have these rotating buckets of hashes. After 20 minutes, you can flush, shift it left, and drop the old hashes, right? And when you join late, you need some trusted node to retrieve the messages, the past messages, and then you will trust that that node has done proper double span checking. And this is not a blockchain system. Obviously, it's like 1,000 times simpler. So, for example, attackers can very easily fork their own messages. They can just send a message with a specially crafted timestamp, like 19 minutes and 59 seconds, and then half the network is going to accept the message and half the network is going to drop the message, and hence you created a fork, right? But you could also have like participants in the system that are providing consensus. So to the opt-in consensus, you could subscribe to one node or a consortium of nodes to determine an order, right? So you would have nodes participants just choosing which consensus engines they would like to subscribe to. But even if you don't do that, you can create a system that has completely stateless payments if the amount of tokens or the amount of work you mine in a message is less than the amount of the atomic payment that you made inside of the message. So let's say, for example, you want to create a rate limited system. So you create some API node on the internet that can take requests from anyone, and then you distribute free API keys. But these API keys have you have to recharge them with requests, right? So, and then to recharge requests, you go on a Waku chat channel and you send some of these proof of work stamps. And you have a bot there in the chat channel which serves this API service. It's listening for messages. It's completely stateless. It just takes each message individually, figures out if the hash is valid, if the recipient of the payment is themselves, right? And if they check if the amount of the payment is covered by the Coinbase, so to speak, of the message, and they will credit you some API credits, and then you would regenerate your access to this free API, and it would be spam protected as well. So it's just one example. And so uses in general, all sorts of chat applications and extensions like games, testing, or some like tutorial cases. And it would also be usable to create like crypto faucets. So you could use this like this fun, risk-free, easy to use way to be onboarded into blockchains, right? So you could get some of these proof of work tokens, transfer between chat participants, and then there is some other bot in a chat that can consume these proof of work tokens, and it gives you some tokens in some wallet addresses, like a testnet tokens or something like that. And you can use this to, let's say, the more sophisticated version of this idea is to instead of implementing this purely at the application layer, at the chat application layer, you could actually push this down and implement this at the relay level. So you could create a Waku POW relay that would actually have the spam protection in the Waku cluster be based on whether the messages are protected by these stamps, right? And this would be not as good as something as RLN for several reasons, but it would be a zero-conf network nevertheless. It would be an open network, public network, always available and spam protected in a way that requires no configuration whatsoever from the client, right? And if you do it that way, then instead of having an explicit command at the chat application layer to say, oh, mine some tokens for me, instead you would get tokens automatically as you use this cluster, right? So you would just use this relay, and when you send messages, you have to protect them, you wrap them in a proof of work, and then you can recycle these stamps that you have to issue from your client. You can reuse them as tokens at the application layer. So you don't even have to mine it, you just accumulate tokens automatically in that case. I have a super simple chat demo. It's actually mocking everything, right? So it's not even connecting to Waku or running the proof of work. It's just showing what the user experience could look like. I have a working RandomX miner system working at this URL here. It's implemented in C++. And some supporting articles in this idea that I called like nano economies, right? So you have these very small value proof of work tokens, and you can use that to bootstrap, like using services and writing games that have very small value tokens that are nevertheless rate limiters and scarce. Right? So I'll just jump right to the demo. It's very, very simple demo. It's just showing that the concept. So you could go to a chat window, and this is entirely at the application level. So it would do something like this. Mine some tokens at 100 difficulty. It would pause a bit while it is mining. And then it would send a message to the channel. Everybody receives the message. And that just means everybody just sorts the message based on the timestamp. And then the other chat participant here could do like mine myself 200 tokens, and everybody would receive, and you're literally just computing a ledger based on message order. You have the full history of messages. the demo handles stragglers. So if you send a message in the past, it will undo the messages and replay them in order. But this is just to show that if you look at the source code, it's almost nothing. It's just a list, right? And on top of this very simple system, you could build other things. So someone would come in and say, oh, what about a consensus guarantee layer? Or what about a snapshotting system? So this list, if it grows too big, you would want to snapshot it, and then you would have a participant in this chat providing snapshotting services and so on. So that's the demo. So thank you.
Thank you, Fabiana. I can bring up, there we go, our esteemed panel. Does anyone have any opening feedback?
Yes. Can I start talking?
Yes, please.
All right. So, I mean, this looks nice. It's clearly, you clearly know what you're talking about. And this seems technically deep. But I have a problem, which is my background doesn't allow me to understand this very well. And I think what I a bit missed was that I was seeing you talk about these things, and some of these things, I of course know what they are, but I missed the sort of the thread connecting thing. So we're doing, of course, you're doing something about Waku, and all of a sudden we're talking about VDFs and payments and blockchains, and I was trying to connect in my head. And I saw, like, you say, okay, this is, you're not implementing a full blockchain, you're replaying messages in order. And I was trying to sort of like piece in my mind so a few things. So first, what problem are we solving? Because you started by saying this is a nice, let's bring the fun back into mining or into hashing. And so I start with that, and I'm like, and then you're solving a much like a problem that to me looks sophisticated, and then I was sort of kind of at the end I was completely lost as to what exactly are we solving, and then I guess I have a first question for you, which is RandomX. Of course I mean I know what a VDF is, but it cannot be accelerated. Is it immune from like, could I build an ASIC that accelerates RandomX, or is it built in a way that you cannot really do it? I guess that's the first question I had. Yeah.
Yeah. So the fundamental reason why one-way hash functions were so vulnerable to acceleration is that they were never originally designed to defeat acceleration explicitly, right? So SHA-256 is super efficient, and that's the point, right? So it's very easy to transform it into a circuit. Now, these blockchain people come along and they say, yeah, we are going to use this as a verifiable delay function, right? It's cool that it can one-way hash something, which we need for the blockchain aspect, but we are using it as a delay function. It's a proof of pain from a remote host, which is what you want when you create a span-resistant system. So some guy did like the RandomX project saying, what if we allocate 2 gigabytes of RAM on the verifier? So that's heavyweight already. Populate it with a bunch of random opcodes, and the movements in this machine are one-way hash functions themselves. So you create a sea of jumping there that takes so you take that to validate one hash. It takes in my laptop 20 milliseconds. And in a desktop, it's like 5 milliseconds, which is actually the bottleneck of this idea. So I didn't mention that in the first presentation, but the actual bottleneck is not the amount of bytes now that would be flowing in the relayed system that's protected by this. It's actually the number of individual messages, because to verify one timestamp, even with a desktop, it would take like 5 milliseconds. And let's say you are crazy enough to say, no, I am going to make something that's like super expensive, because so this 2 gigabyte machine, it's made for CPUs, because CPUs are good, like a branch prediction and jumping and whatever. And if you throw this to a GPU or a specialized circuit, you're just going to have to replay, reproduce Intel, basically, right? So you're creating
Okay.
you're doing an entire
It's
Intel general purpose processor for this, right? And let's say you're crazy enough to do that, you can actually each this 2 gigabyte machine is actually randomly generated. It's generated from a key.
okay.
So Monero, if they are attacked by this hardware, they can just make like a hard fork and switch the 2 gigabyte matrix in like 5 minutes, and your $100 million projects go down the drain. So you can declare the problem solved. So the fastest Monero, so this is like 5 to 6 years old now, and the fastest like hardware acceleration of Monero mining is 20x. So 20x is super doable, right? So you can participate in your CPU and accept that some other guy is mining 20 times faster with the same energy expenditure, but they also had to spend capital in a machine that's much more expensive, so it doesn't pay off, right?
It's not going to shift things that much.
No.
Okay,
no.
interesting. So it just breaks the sort of constrained computational model of GPUs by using this sort of large randomly generated machine, basically.
It's a horrible hash function, but it's a great delay function. So
okay, amazing, very good. Okay, and then I'm back to like I'm not entirely sure I understand the problem you were solving. So
yeah, so that's the other problem. I've been thinking about this idea for over a decade. so it's actually ameliorating multiple problems simultaneously. So the selling point is, if you do this, there's this lot of things that you can benefit from, right? So for example, let's say you're doing this just at the application level, right? So before we go even into Waku, you could implement the system, as I mentioned at the beginning very quickly. Any distributed system can use this. You can implement this as a website. You can do computerjuice.com, right? And you submit a stamp to it, and it keeps a centralized database of these balances. And then you can have API nodes just passing through this service to get payments. But then it's centralized, right? It's not that cool, right? You could do a full-on blockchain for this. So you could create a smart contract. I think that has been done already, if I'm not mistaken. I think Frank pointed me to some implementations, blockchain implementations of this. So you create an ERC token whose mint function is the amount of work. So you submit a proof of work to a contract, a layer 2 contract, probably because you cannot run the verifier for this proof of work in layer 1, or you use oracles, right? And then these oracles or this layer 2 verifier will say that the hash is correct. And then if you submit a stamp that is 200 difficulty, it will mean 200 ERC tokens for you. And then you can use these like testnet tokens, right? So this is a way to distribute testnet tokens with a contract that is a faucet. And this is a real problem, right? So you have these faucets that you use a while and they break, and then you have to use another one. So this is a real pain in the ass, right? And you would create a faucet system that is permanent in this way, right? So this is how you get testnet tokens. You churn a bit on RandomX on your machine, and until we have quantum computers, the system will work, and you can reference it in tutorials and whatever. How do you get your testnet tokens, right? So this is slick for that, for example. And then I was looking at Waku, and my mind just went, because I said, you can actually put this thing inside Waku. You don't need to put this in a website or even a blockchain. Then you can do the very stupid thing there that I showed. You can actually create this as a status desktop plugin to your chat room. So this can run in a chat room. You can just put a program that has a list, and people are sending these special messages to the channel that have that. And now imagine that you have these little bots. Do you remember when chat was full of bots and like an IRC? And then you have so you have a chat economy. So people are sending these tokens inside the chat, and it is secure. You cannot like mint these tokens willy-nilly. To cheat this social game, you would have to actually do something that's very hard, which is to break a proof of work token. And then you can imagine where this goes. You're creating like this Roblox kind of economy entirely from the chat application up. And then you can do all sorts of fun Robloxy like things where you hook up some API server to the chat. And now you're buying, hey, I bought some API credits here. And you have this mini cloud economy inside the chat room. And I think that's this problem we would be solving there is like a self-imposed problem, but it's the opportunity of creating this little area where you can have all these kind of demos and learning. And it's a place where people can go and start thinking about tokenization without any financial stakes. So that's one of the problems we would be solving. And then, of course, after you've done that, what's the next logical step? Why not push this to the relay level? So if you're Waku core developers, like I want a relay protocol that is like this. So you want Waku node 2 -- POW relay. Why would you do that? Because then you can create a public network that's not as efficient as the RLN network. It's capped at every cluster to, like, let's say 3,000 messages a second. But with 3,000 messages a second at zero setup, you can have an example that connects to the public network. It's not even like a local Docker kind of thing that's starting a private network. It's not like the public network that's RLN protected, that has to have some setup there that you have to register in a contract. So it's really zero conf that way, right? But it's not intended to solve the problem of messaging at large, right? But it can solve messaging for the more restricted set of users of these chat applications, which are people who are developing things and testing things at their level. It can't a cluster of this will not support 10 million users using status. That's a job for RLN, but it could support 300,000 developers in the same cluster playing around, right? So with zero conf, right? So, and then you could go on from there. So I hope that's clarified a little bit. I know it's a confusing idea, but
that's better. Okay. I have more questions, but I don't think we have time, and I have to let Pedro talk as well. So, since you've been thinking about this for a decade, do you have any written references on this so that we can maybe follow? Try to read up on.
Yeah, so my most recent thinking is these supporting articles here.
All right, okay. They're right there. Okay.
Yeah. But just me, so just ping me and talk to me. I can talk endlessly about this if you're more interested. So.
All right, sounds good.
Pedro, any feedback?
I'm a proof of work enjoyer. I have thought about, from my very non-technical point of view, I have thought about Waku POW relay as well in the past, because there's always an initial smart contract interaction that you need for RLN. And I was thinking, what if instead of RLN, there was a requirement to do some non-trivial computation instead that would also rate limit the user in order to start messaging, and it would be 100% local in a sense to participate and be able to send messages. And that's why I like proof of work, because you can just start mining and you don't need to go buy you have the option to go buy the tokens as far as I understand here, in a sense, because they are transmissible, right?
Yes. Yeah.
So you have that solution as well. But if you're in a place where that option isn't there, it's very meritocratic, and like philosophically, it's very interesting that you can just mine and go. So I like it.
Yeah, so this concept of your computer suffering for a while and this generating a thing that has economic value, it's really mind-bending. It's been 15 years since Bitcoin appeared, and I still don't understand how Bitcoin is worth $2 quadrillion. It's like the energy expenditure of an entire country, and that's $1 trillion for us. It's not a cost; it's a value. It's like mind-bending. So it's one of these things that if we implement this, I'm not sure what happens, but you're basically creating a value economy instantly inside a chat room. And that's, I don't think I can predict if that's like people going, meh, not use it, or just go insane. I don't know. So
yeah, I think proof of work, it's like they're not all created equal, right? But still, if we don't need to think about the economic or market value of the proof of work. I think we need to think about the utility of the proof of work in this context, which is very clear. But what I ran into is, what if there's a bad actor that has access to this new proof of work network cluster and has some resources and can just compute tons of proofs of work and end up spamming it regardless? Like, does the difficulty adjust to this, and will it hurt the other users, or will this node in particular be like, what happens here in this scenario?
Yeah,
I mean, this is a hackathon project, but
yeah,
but still.
Yeah, so you have, so this is network protected by this is more for it's not the most efficient network, right? So you're setting the bar for the minimum amount of work that you need to provide. So that's if you use it at the relay level, because one of the ways to use this, so this is quite confusing because you can use it two ways. So you can have a network that's protected at the relay level by RLN, and then unbeknownst to the entire Waku stack, permissionlessly, someone is just going to take this idea and implement it at the chat level. They're going to implement a chat application or a status plugin that's going to do this just as a little game inside of a network that's already spam protected, right? So in that case, a bad actor cannot hurt anybody because they are not obtaining anything. They're just chatting at the same rate that RLN would already allow them to do inside the chat, but then they would have an additional level where they would torture themselves by computing this proof of works because they want to win in a token game inside a chat room that is just a timestamp order ledger. And I think if you have that kind of random access capacity, you will go mine Monero instead. So I wouldn't use in that case. But let's say we did do this at relay level, and we created this public network. We do some tutorials about it, and it's open, right? So can someone go there and destroy it? Absolutely. If you set the per message, so remember I said, I'm just a guess, so like 3,000 messages a second is the amount of stamps that a validator can verify. More than that, it will have to queue those, like when Ethereum queues like the mempool, right? And then it can dispatch like 3,000 per second. And so to keep this, disincentivize people to fill this queue with garbage, there is an amount of work minimum amount of work that you set per message, right? This could be quite high, maybe to say hi in the chat. If this is at the relay level, my laptop would have to pause for like 2, 3, 4 seconds to send one message, right? And it's not about even the message size. It's just that any message, even if it's a small one, is going to consume that maximum amount of messages that the relays can process in that cluster, right? And so you have to set up, that's the sensitive parameter. What's the amount of work that you have to imprint the difficulty target per message? And your network is protected at that difficulty times 3,000. So if someone has 3,000 times, they have like 3,000 computers, they basically ruin that cluster, right? So that's another feature of these kind of nano-economic systems, is that they are embarrassingly parallel. You can just spin another one. Oh, this shard is full. That's a problem that we like to have. So this is also kind of signifying all usage, independent of whether this is an attack or legitimate usage. You're not distinguishing between them. Like, people are using it, so it's a success, so you spawn another one, and so on. So you can actually just spawn several of these instances, and these economies can run entirely in parallel because there's a lot of people inside each one individually that you can have fun in them. It's just like when you have a massively multiplayer game sharded, right? So World of Warcraft shard, it's an entire copy of the entire universe, and there is, I don't know, 300,000 people in there. That's enough. So you can just move to another shard, play again, create another character, create another account with more tokens. And so I think this is very tolerant of attacks in that sense, is that what even is an attack? It's usage. So, well, it's successful, people are using it, so just create another shard, and then you can move all your testing or your examples there as well. So,
yeah. Very cool. I don't have any more comments.
Well, very Exciting stuff, certainly. Thank you, Fabiana, for
Mhm.
the presentation, for the double presentation duty today. Thank you very, very much. Well, that concludes our second round of demos for the second Waku Internal Hackathon of the year. Thank you to all of the presenters today and Fabiana and Arseni. For this session, our panel members, Giuliano, Pedro, thank you for participating. For anyone who is interested in finding out more, you should go immediately to logos.co and waku.org and begin your journey down the rabbit hole. Join the communities, follow us on Twitter, subscribe on YouTube, all the places. And as I check the chat, thank you everyone for following along. Stay tuned. Lots coming. Lots happening. Hope everyone has a wonderful rest of their week. We'll see you all very, very soon. And with the cue of the music, we will gracefully shut down.